Hi, we have already seen what are zero values. For an interface, the zero value is nil. This is an empty interface. If you print the line 11, it will be true, but there is a catch. For an interface to be nil, both the value and type must be nil. Let's say I have a pointer of type a string. Because I haven't pointed it to anything right now, s will be nil as zero value of a pointer is nil. Let's also print it. If I assign s to I, now the type of I is no more nil. If I try to print this, it will be false. The first one is true, next it's true, but the 15th one is false. Internally, a interface is implemented as a struct with two pointers, okay, one pointing to type and the second one pointing to value. If the value is not nil, that means type will also be not nil. I can't have a value without a type. Okay. So empty interface states that variable can store any value whose type implements zero or more methods. Every type in Go comes under this empty interface. If I say int, it can store a value and it implements zero or more methods. I can assign 20 to I, hello, a string to I, a struct to I, anything to I. Let's say you have a function where the input parameter can be of any type, right? So if you want to specify that, I can use a empty interface. In the function, you can write a switch case where you will handle the situation depending on the type of the interface you are getting. Next, let's discuss about type assertions and type switches. Type assertion names the concrete type that implemented the interface, or another interface that is also implemented by the concrete type underlying the interface. I'll give an example for that. In here, I've declared a variable m of type myInt, which is a user defined type. Underlying type is int, and I assigned that m to empty interface I. So type assertion is nothing but the type is myInt. So this dot myInt is nothing but the name of the concrete type that implemented the interface. So if I say s plus 1, that should be 2. If I change it to string, then the compiler will throw a panic. You see, interface conversion is of type a main, a myInt, and not string. And I can also not use int. You can see. So in Go, you should be more specific about the concrete type. You should only use myInt, even though underlying type of myInt is int. You shouldn't be using int. You should only use myInt, that is the first underlying type. Next, so previously I have given you an example where you can write a function with a parameter of type empty interface, and internally you can handle depending on the type. So yeah, type switches are useful here. Switch a dot type, this is how you'll get the type of a, and if it's nil, I'll do something. If it's int, some other way, a string, you can go on. Let's say a default case. This is how you will handle processing depending on the type that you get. That's about type switches. We have seen the concept of OK idiom to check the zero value in maps. In the same way, because type assertions are very specific and it might throw a panic, it's better to use comma OK. Okay, I dot my int. This if not of okay, I'll return from here. Otherwise, I will go ahead and increment the value of s, and let's try to do that. So you got 2 if I say it as int wrong type assertion. That's about type assertions.